For centuries, we believed the Pacific held the ultimate crown of the deep, but recent discoveries are challenging everything we thought we knew about our planet. Deep beneath these restless waves, in the shadows of the Atlantic, a secret has been hidden from human eyes since the beginning of modern oceanography history. We are entering a new era of exploration where the maps of our world are being rewritten by data that defies over 100 years of science. Is it possible that the Atlantic Ocean hides a secret deeper than the Mariana Trench? Scientists are now questioning the absolute supremacy of the Pacific's Great Abyss. Our journey begins with the ghosts of past expeditions, using tools that were once thought to be the height of technology, but are now merely relics. Early explorers faced the crushing weight of the unknown, where ancient instruments were often obliterated by the immense pressure of the ocean's deepest, darkest, forgotten corners. The rhythmic ping of the sonar echoes like a heartbeat in the void, searching for a bottom that seems to fall away further than any human expected. Welcome to a world where the records are breaking, and the silence of the deep is finally being translated into the language of revolutionary, modern, scientific data. In the cold embrace of the Atlantic, the Puerto Rico Trench stands as a sentinel of mystery, challenging the very foundations of our global maritime understanding today. Every meter we descend brings us closer to a truth that could shift the balance of power between the world's two greatest and most formidable liquid giants. Prepare yourself for a journey that redefines the limits of our planet, as we dive into the heart of the great debate over the ocean's ultimate depth. For over a century, the Pacific Ocean has held the undisputed title of the world's deepest realm, home to the legendary and terrifyingly deep Mariana Trench. This massive scar on the Earth's crust reaches down into the mantle, a place where the sun never shines and the weight of the world is felt. To visualize its scale, imagine dropping the world's tallest skyscraper into the abyss. It would be swallowed whole, disappearing into the darkness with miles to spare. At nearly 11,000 meters, the Challenger Deep is the gold standard of geological extremes, a place so remote it feels like another planet entirely. Famous explorers like James Cameron have ventured into this silence, bringing back images of a desert-like seafloor that seems frozen in time and ancient geological history. In this extreme environment, life takes on bizarre forms, surviving under pressures that would crush any normal creature into dust within a fraction of a second. But how certain are we of these measurements? The density of water, influenced by temperature and salt, can create illusions that deceive even our most advanced sensors. Oceanographers are now realizing that the vastness of the Pacific might contain hidden variables that have skewed our understanding of its true, absolute maximum depth. The throne of the Pacific is built on shifting ground, where tectonic movements and volcanic activity constantly reshape the very bottom of the world's largest ocean. As we deploy new technology, the certainty of the past begins to crumble, replaced by a complex puzzle of data that points toward a shocking new reality. If the Pacific is the king of depth, the Atlantic is the rising challenger, hiding its secrets behind layers of cold, turbulent water and complex geological structures. The time has come to look eastward, toward the Atlantic, where a long-held scientific consensus is about to be put to the ultimate test of modern exploration. Beyond the familiar maps lies a frontier that remains largely unmapped, a liquid wilderness where the rules of depth are being rewritten with every new expedition. Small discrepancies in measurement can lead to massive discoveries, and the quest for precision is leading us into the deepest valleys of the Atlantic seafloor. Each piece of evidence gathered from these depths adds a new chapter to the story of our planet, revealing a landscape far more dramatic than imagined. The forces that created the Mariana Trench are also at work in the Atlantic, carving out canyons that might rival the greatest depths of the Pacific realm. Scientists are now connecting the dots, using satellite data and deep-sea probes to uncover the true profile of the ocean floor across the entire global map. We must acknowledge the limitations of our ancestors' tools while honoring their courage as we prepare to surpass their greatest achievements in deep-sea mapping. The throne of the deep is no longer secure, and the world is waiting for the final confirmation of what lies at the bottom of the Atlantic. As we move into the next chapter, the focus shifts to the North Atlantic, a place of cold water, high stakes, and hidden geological wonders. The North Atlantic is a chaotic and unforgiving frontier, where the surface violence masks a far more complex and mysterious landscape deep beneath the waves. Here lies the Puerto Rico Trench, a massive scar that marks the boundary between the Caribbean and North American tectonic plates, plunging into the abyss. The contrast between the vibrant surface and the eternal darkness of the trench is a reminder of how little we know about the majority of our home. The 5 Deeps expedition set out to change this, led by the DSSV Pressure Drop, a vessel designed to conquer the most extreme depths on Earth. Equipped with state-of-the-art multi-beam sonar, this mission sought to map the seafloor with a level of precision that was previously impossible for human researchers. What they found was a dynamic and ever-changing world, where the depth of the Puerto Rico Trench appeared to be far more significant than historical records. Old data from the 1960s, based on limited technology, is now being replaced by high-resolution imagery that reveals the true jagged nature of the Atlantic floor. The Puerto Rico Trench is not a static hole. It is a geologically active zone where tectonic forces are constantly pulling the Earth's crust apart. Recent measurements suggest that we have drastically underestimated the complexity of this region, with new, super-deep points appearing on our latest maritime maps. Measuring depth isn't just about timing a signal. It requires understanding how sound behaves in the cold, dense, and salty waters of the deep Atlantic. When the numbers began to fluctuate, the team realized they were witnessing something extraordinary, a depth that challenged the very records they were sent to verify. This is a realm of giants, where the scale of the landscape is so vast it defies human perception, hidden beneath miles of cold Atlantic water. The pressure here is absolute, a physical weight that defines the limits of technology and the courage of those who dare to explore these depths. By refining our calculations of sound velocity, we are uncovering hidden pockets of depth that were once invisible to the older generation of oceanographers. Are there spots in the Atlantic that exceed the Mariana Trench? The data is tantalizingly close to proving that the Atlantic is deeper than we thought. In this silent world, every discovery feels like a revelation, a step toward completing the map of the final frontier on our own home planet. The Atlantic's currents and density layers make it a difficult environment to measure, but they also hold the key to its most profound geological secrets. As we process the latest data, the true face of the Atlantic floor is emerging, and it is far more rugged than anyone ever predicted. The mission continues, driven by the need to know exactly how deep the rabbit hole goes in this vast, cold, and mysterious Northern Ocean reach. The truth is hidden in the numbers, and the numbers are starting to tell a story that will change the world's geography books forever. Science never stands still, and today, we are using tools that our predecessors could only dream of to unlock the final secrets of the abyss. A tiny error in calculating the speed of sound through water can result in a depth measurement error of hundreds of meters in the deep. We have moved from dropping lead weights on ropes to using sophisticated lasers and sonar arrays that can map the seafloor in stunning three-dimensional detail. In labs across the world, the debate is heating up as new data points emerge that don't fit the classical models of ocean floor topography. Processing millions of sound pulses per second, our computers are reconstructing the seafloor, revealing features that have been hidden for millions of years of time. Thermoclines and haloclines act like lenses under the water, bending our signals and forcing us to rethink how we calculate the true distance to bottom. The quest for the absolute truth requires a level of precision that pushes the boundaries of mathematics, physics, and advanced modern engineering to their limits. Robotic explorers are now our eyes in the dark, venturing into places too dangerous for humans to bring back the most accurate data ever recorded. As the resolution of our maps increases, the bottom of the ocean is revealed to be much more complex and potentially deeper than previously recorded. Every breakthrough is a moment of triumph, a small victory in the long history of human exploration and our desire to understand the unknown world. Even from space, we are learning more about the ocean floor by measuring the minute changes in the sea surface height caused by gravity's pull. This gravitational dance reveals the hidden peaks and valleys of the deep, providing a global view that complements our ship-based sonar mapping efforts on site. The evolution of our maps is a testament to human curiosity and our refusal to accept that any part of our world remains a total mystery. At the bottom of the Atlantic, these silent sentinels are working around the clock to capture the secrets of the abyss for future generations of scientists. The gap between the Pacific and Atlantic is closing, and the scientific community is buzzing with the possibility of a major discovery that changes everything. We are on the verge of a paradigm shift, where the old certainties of the deep are being replaced by a new and more exciting reality. Behind every discovery is a mountain of data and the dedicated work of individuals who spend their lives trying to solve the puzzles of nature. Engineering for these depths is like building for outer space. There is no room for error when the pressure is measured in tons per inch. From these centers of innovation, we are launching a new age of discovery that will finally map the remaining 90% of our ocean floor. The connection between technology and exploration has never been stronger, and the results are starting to speak for themselves in the latest deep-sea records. Our sensors are locked on, our data is clear, and the truth about the Atlantic's depth is finally coming into sharp, undeniable, and shocking scientific focus. As we enter the deepest zone of all, we must prepare to face the most extreme environment on our planet, where life and death coexist. The Hadal zone, named after the god of the underworld, is a place of total darkness, extreme cold, and pressure that defies human imagination and scientific limits. Inside the titanium sphere, the tension is palpable as the pilot watches the numbers climb higher and higher, venturing deeper than most humans ever go. Every creak of the hull is a reminder of the thousands of tons of water pressing in from every side, seeking any tiny weakness in the steel. At the bottom, the lights reveal a world of ancient sediment, a silent record of the Earth's history that has remained undisturbed for countless geological eras. Even here, in the most hostile place on Earth, life finds a way to exist, adapted to the extreme conditions in ways we are only beginning. The pressure at these depths is equivalent to having dozens of heavy jumbo jets stacked on your thumb, a force that would crush most materials instantly. In the Hadal zone, there is no margin for error. A single mistake or a structural failure means instant destruction in the blink of a human eye. The courage of these explorers is driven by a singular goal: to reach the very bottom and settle the debate about which ocean is truly the deepest. When the sub finally touches down, the dust clouds it kicks up are the first signs of human presence in a place that has been hidden. From the perspective of the abyss, we are but a fleeting moment of curiosity in a world that operates on a timescale of millions of years. We are here to bear witness to the unknown, to document the final frontier and bring back evidence of a world that few will ever see. This interaction between the human world and the deep sea is a reminder of the interconnectedness of all life on our beautiful and mysterious blue planet. The data collected here will provide the final pieces of the puzzle, allowing us to compare the depths of the Atlantic and Pacific with absolute certainty. Every sample is a treasure, containing clues about the geological history of the ocean and the evolution of life in the most extreme conditions on Earth. Operating a vehicle in this environment requires incredible skill and a deep understanding of the physics of the deep sea and its unpredictable, dark currents. It is a landscape of extremes, where the geography is defined by the immense weight of the water above and the slow movement of tectonic plates. In the darkness, we find beauty in the details, the way light plays off ancient rocks and the delicate forms of life that thrive in total silence. As we begin the long journey back to the surface, we carry with us more than just data. We carry a new perspective on our planet. The return trip is a slow transition from the underworld back to the world of light, passing through the various layers of the ocean's life. The mission is a success, but the work is only beginning as we prepare to analyze the wealth of information gathered during this historic deep-sea dive. Emerging from the deep, the explorers are greeted by the warmth of the sun and the realization that they have just witnessed the heart of Earth. The truth is now on these drives, ready to be shared with the world and to change our understanding of the Atlantic Ocean forevermore. This data will be integrated into the global map, providing a complete picture of the deepest parts of our world for the first time in history. We have looked into the abyss, and what we found was not just a number, but a testament to the incredible forces that shape our living world. The Hadal zone remains a place of mystery, but with every dive, we are bringing a little more of its secrets into the light of science. We often think of our world as a finished map, but the reality is that we are only just beginning to understand the true shape of Earth. The trenches of the Pacific, Atlantic, and Indian Oceans are not isolated pits. They are part of a global system that regulates our planet's climate. The discoveries we make today will inspire the next generation of explorers who will take our technology even further into the unknown depths of space. From the Java Trench to the South Sandwich, each abyss has its own story to tell, adding to the complex tapestry of our planet's geological history. The mapping of our own world is far from over, and the shock of these new findings is a wake-up call for all of modern scientific research. We have mapped the surface of Mars and the Moon in more detail than our own seafloor, a fact that drives our continued search for knowledge. The race to the bottom is not just about bragging rights. It is about understanding the fundamental processes that make life on Earth possible for us. These deep-sea environments are the birthplace of many of our planet's resources and the key to understanding the origins of life in extreme conditions. With every new mission, we are filling in the blanks on our map, one data point at a time, until the entire world is finally known. The integration of this new data is creating a more accurate picture of our world, one that will be used for centuries to come by scientists. The journey is long, but the rewards are immeasurable as we continue to push the boundaries of what is possible in the name of discovery and science. The exploration of our oceans is a never-ending journey, a continuous cycle of discovery that keeps us humble and curious about the world we live in. The deep sea remains the final frontier, a place of mystery that will continue to challenge and inspire us for as long as we seek truth. We are the explorers of today, building on the legacy of the past to create a future where the entire world is known and fully understood. The shock felt by scientists today is not just about a number, but the realization that the race to explore the abyss has only just begun.